Okay, so exception handling. Right. What could go wrong? Well, you name it pretty much in you know, the internet and so on and so forth, right? So there's all kinds of things that we could deal with. But we're going to start off, as I say here, focusing on issues we've learned how to deal with before, right? The ones that come to mind probably right away are validation errors. Now, we took the poor man's approach in our demo for the last lab of actually writing some client-side series of ifs, right? Way back in term 1 in your first JavaScript course, you learned to write JavaScript code like that to do really basic validation of a web form, okay? But, there's obviously a lot of problems with that, and we've seen how nice, for example, ASP.NET MVC is, and, can we get something closer to that than writing this custom validation code for every type of client entity that we might want to deal with in all of our different clients and so on. Another thing then is database errors. Okay, we learned how to handle database errors in MVC, and you did the same thing with web forms, right? So you get all those things like referential integrity errors. You try to delete a parent with existing children, etc., or create a child that's not assigned to a parent, vice versa, right? Domain integrity errors, things like unique constraints, okay, that you might violate and so on. And that's over and above anything you can do with basic validation as well. And then, of course, things like concurrency conflicts, right? How do we actually make our application robust to handle those properly? Sure, we all know by now that we can just live with the last save wins approach if updates are infrequent and so on, but it's really not professional, and it's not very hard to implement at least basic notification that someone else has changed the record, right? So there's those things that we've all dealt with in the past, and we're going to look at how we do those here as well. And of course, there's the other aspect of what if you can't reach the service? Right now, all our apps so far just crash, right? They crash and burn if there's no actual web API available. So, that can be a little complicated, especially with asynchronous operations and so on. So just for that, we aren't going to go a full-blown approach. We're going to cover the most basic and essential aspect, right? So we'll start with that, get that out of the way first. By the way, I've got some links up in Blackboard to a number of articles on this topic in general. One of them is a list there on the ASP.NET site about global error handling with WebAPI 2. And he goes into quite a fairly advanced covering of how to actually log errors that can't be reported. Things like you lose the request, the response, the connection basically halfway through the middle of something and things like that, right? So pretty advanced stuff, and I encourage you to have a look at it. If not now, then you're probably going to be looking at it when you get hired to do this kind of work professionally, right? But in the meantime, just to keep it simple, let's just deal with this simple question here. What's our poor little client application supposed to do if, it calls out, Mr. Web API, and nobody answers, right? There's nobody home. Well, okay. So the very quick answer to that is every time we're going to ask a repository, this isn't something we put in the repository, but when we ask the repository to call the database, right? Then we just always wrap that in a try-catch. That's one tried and proven approach. Get the pun there. That we can use to catch that situation and at least, let the user know, right, that there's a problem with the connection. We can even do the kind of if, okay, examining messages inside the exceptions themselves, see if it actually is mentioning the connection to the server, and just let the user know that it's something to do with that. So you can even, if you go to the extent of perhaps offering to refresh and so on, check that the site's up and refresh and things like that, then that can be done as well. So that's just your basic simple approach, but at least you don't crash anymore just by doing that, right? Okay, so let's get on to the more interesting stuff, the stuff we've done before. Validation, database errors, and concurrency, right? So let's remember that DRY concept, the dry. Don't repeat yourself, right? Don't repeat yourself. I know. Ooh, you caught me. Oh, groan. Okay, I'm going to repeat myself once more, or maybe more often than that. Validation logic is best in one place, right? So the kind of code that I committed the sin of writing the other day and showed you in class of, okay, making a custom little set of ifs to check if this is filled out and that's in that range and so on. Well, writing that code inside every page of every client application and so on and so forth is really ridiculous and a waste of time, especially because it has to be checked again on the server, right? And that's something our little application so far doesn't do. If you could get in there somehow and send bad data, not checked by our little client application itself, there's no protection for things like something that won't actually cause the database to crash, but is an additional validation error. There's no protections right now. So really, we want to do it in the best place, and that is, as we've discussed before, the model, right? The model itself, I know in the old days we used to put it all in the database, okay? But now the model, that business object in the middle of the interior arrangement, middle more or less, is proven to be the best place to put this kind of thing. So whether we're using just our data annotations and the validation that comes with them, or something like our iValidatable object interface and so on, okay, it's still going to raise model errors for us. And hey, we're going to see that we can actually make use of those model errors, even though we're only talking through HTTP responses. Right. So as I said, even if we do a great job of writing client-side validation, that doesn't take care of the server side. So if we do validation with the usual approach in the model, then we can possibly have the benefit of doing both in one location. And you might think, well, that's no big deal. I just have to modify code in my client as well. But think about maintenance. After you have 10,000 people out there around the world using your software, you decide you have to change something in the client validation code and how it's written. Well, then you have to get every single person out there to update their software. Believe me, end users are terrible at updating their software, and they'll resent you if you make them do it too often, right? Just look at how much we all love our Windows updates. Okay, so it's much better to keep it, somewhere that you have full control of it and the client isn't dependent on actual updates to the client application. Okay, so how are we going to tell the client? Well, guess what? This code was already there. Okay, if you looked in our WebAPI controllers, the scaffolding of the project itself with WebAPI 2 did things like this, right? If model state is valid, if that's not true, well, then we can just return a bad request, which is a particular type of animal available in WebAPI 2, and just pass it the model state. What exactly happens? Well, right now, nothing. We aren't paying any attention to that data, even though it's being provided ever since we started working with WebAPI. It's always been there in the content of the response sent back, but we just never bothered to look yet, right? To be honest with you, there are a few issues. It's not the easiest thing to do, so that's why we've left it till now. Okay, so it does involve this HTTP action result, okay? This is new in WebAPI 2, and basically we would just do HTTP response message, was usually what was returned from most controller actions in WebAPI the earlier versions. So they've added this abstraction, and it cleans up the code tremendously. Some people say, oh, well, then I can't have full control over what I'm doing, but you can always write code the old-fashioned way if you really want to. But it really, as it says here, moves common logic to creating these responses into separate classes, so it just gets them off the screen and out of the way. Less chance of messing them up, and it just makes your code that you are responsible for writing much easier to read and cleaner on the screen, right? It makes the intent of the action clearer. You can tell that those 3 bullet points I stole from Microsoft's ASP.NET website. I have to give them credit. Anything that's worded with bigger words than 2 syllables, probably I didn't write. Okay, all right. So, provides a collection of predefined result helper methods. Okay, so that's why we'll look through our controller code right now, and we'll see lots of these peppered everywhere. Return not found, right? Which basically forms a response message for a not found result, and so on. Return OK, and then just pass it the object that you've materialized. Okay, and that basically generates a OK negotiated content result. Content will being the actual name value pairs described in JSON format of the object you want to then materialize again on the client, right? So that's what we have to work with now. So that's good that plumbing is mostly already in place in our controller, okay? But really what we're looking at is more or less a 3-step process here, okay? So step 1 as I call it, tell about the error, tell about the problem, right? So this is done in the API, particularly in the controller. Determine what the problem is, step one, okay? Then prepare an appropriate HTTP response, because that's the point I really want to drive home in our discussion right now, is the fact that this is totally disconnected. The only way these communicate is through HTTP requests and responses. So it's not like you can just raise an exception there and catch it here, right? There's just that connection doesn't work. So it has to be all done through these standard HTTP responses that have been around for many years, just been refined slightly in recent times. So we prepare the right response, add whatever error messages into it that we need to, if there's an exception of some sort, and then we send it. So that's step one, and that all happens inside the actual WebAPI controller. So step two then, right, is we listen for those. And as I have in brackets here, that's part of the repos job, the repository. Remember, that's how we decided we would create our client application, is we would define data repository classes that would look after things like adding a new client or product or patient or whatever, right? Updating it and getting it by ID and so on and so forth. So how it does it is inside the repository, which we can rip out and plug in a different one as long as it implements the interface we've defined for it. Okay, so that's where this step two code goes, right? So in the repository, we'll analyze this response. Now here's where most of the work actually comes in, right? Then parsing out the messages, okay? This is where the biggest challenge is. Create an exception. Now, some people might argue, some people don't like exceptions. They say there's too much overhead, performance issues and so on, but I don't fully agree with that. You know, people also argue that they'd rather keep their money in a mattress, but I kind of like banks. They give me a certain sense of confidence. I know how to use them. I know how to use the debit machine there. So, you know, sometimes infrastructure that's been planned and built and tested and true isn't always bad to use. Sure, later on if you want to play with some of the other approaches, that's fine. But as the author of the main message I got a lot of this stuff from on the internet says, you know, exceptions are not the greatest evil in the world. Okay, so we'll catch that, and then we will create an exception based on the information we read in the HTTP response. So now we're in familiar territory. So working in the client application now, in the repository, and boom, we can create and throw an exception, right? There we go. So now in the actual code that is doing the work, you might say, and this is probably sitting in like the code behind of our page, or perhaps in some library if we put it in there, whatever, right? We'll actually catch all of these exceptions that the repository has thrown after it's scratched its head and figured out what the response actually means. So that's good. So we'll handle those exception types, and usually the end result, other than simply preventing a crash of the system, is to just tell the user, hey, guess what? We just had such and such happen, right? You know, a concurrency error, or, oh, you left out this critical piece of information to add the new record, whatever the message really comes down to. So the three-step approach then, I broke it into the three because it's really in three different places where we put code. Okay, step one is the API controller, step two is our repository class in the client, and step three is the actual code calling the repository to do the work for us, whether it's in a code behind or wherever. So we'll break this down a little bit more, but I want to give the overall step-by-step approach a discussion first. All right, so step one then in the Web API controller. How do we do this? Well, as I said a minute ago and pointed out, there's a lot in there already just from the default scaffolding. As we saw with MVC as well, a lot of the work is done for us ahead of time. We just usually have to go in and refine things. And there's more than one way to approach this as well. I'm not trying to say this is the only way, but it's the first way that occurred to me when I was learning this, and it seems to work really well, so I'm happy with it. Okay? Oh. So we've already seen this code, right? So we can just, you know, if say there's a validation error, we can just send a bad request, HTTP status 500, I think it is, status code, and then bundle up all the data about the model state. So that happens in the controller, something like this, right? So that's the one, but, oh, sorry, this is another example. So I was just meant to say, here's one example, here's another example. All right, so with our update concurrency exception, well, we've done this type of code before in MVC. Okay, you get two people changing the same record at the same time. You'll throw one of these exceptions. So, I can simply check, well, maybe I'm getting this exception because it's already been deleted, right? So I'll just use my bad request and that same code 500 error message, but this time I can pack in, quite simply, just pass a string for the message I want to show the user. Let them know this is a concurrency error, patient has been removed. I can know that because patient exists is false, right? That code the patient exists code is already there in the scaffolding code written by the controller, for the controller. Else, okay, just let them know that the patient has been updated. So if it's not that it's deleted and we have a concurrency error, then I can be pretty well totally confident that it's because there was actually a change made by somebody else, right? So the timestamp has been updated and away we go. Another example to look at is a possible thing we could do, okay? This kind of exception handling, right? So we might have a catch for a data exception. In MVC, we did this before, and this was the kind of place where we'd look for things like referential integrity errors or domain integrity errors, like this one, the violation of a unique constraint, a secondary index forcing unique OHIP number in this case on the screen, right? So if that is the actual message, and we're sure of that because it's referencing that particular named secondary index right in the database and the message coming back from the database, then I know exactly what the problem is and I can give a specific message, right? If that's not it, but there was some other data exception, then I'll give a more general message, but at least I'm telling them it's something to do with saving to the database, that it wasn't to do with the web connection or anything like that, right? Giving them as much information as we can when we're confident we know what the problem is. So that's all sort of step one and the kinds of code that we can add, okay, to add extra value to what information is being provided by the API controller itself. So let's switch to the client now and talk about what we can do here. In the repository, right, okay, how to analyze the response message, right? Well, that, is certainly a challenge. So we have something like this. We get this bad request status code, and the model state is bundled in the content of the response. How do we analyze it, right? Well, if we look carefully, we'll see that the content is in JSON format. But, just because it's in JSON doesn't mean it's in simple name-value pairs. It's hierarchical, right? And the trouble is as well, if you look at a few examples online, you'll quickly see that it's not always consistent. Sometimes there's no name for the value and things like that, okay? So, you might get something that looks a bit like this. This one is actually good. I could work with this one with no problem. Okay. Message, the request is invalid, so that's a name value pair there in JSON. The next one, the name is model state, but the value, you'll notice, is an array of more name value pairs, right? No problem. It's easy to serialize this, deserialize, I should say, this kind of JSON, because, this looks pretty consistent, and you could use a dictionary or other dictionaries are used a lot in C# to analyze a JSON payload. But the problem is, it's not always going to look like that. We've seen before if you do something like a iValidatable, right, on a class, and you want the error message to show in MVC right up in the validation summary, well, you don't actually pass a name, right? That's where the name usually comes from, is the name of the field where to show the message. That's how we've used that in the past. So there might not always be a name to the name value pair in this array of model errors, right? So it makes it very hard to write code to pull all the data out. That's my point. Okay, so how do we solve this mystery of how to slice and dice this when we really can't predict the arrangement of the data inside the content of the message, right? And so one answer up in Blackboard, I've put a link there to a series of articles online about this whole issue of error handling and exception handling. But one of them in particular is Unwrapping HTTP Error Results by a guy named John Atten. Okay, so the link's up in Blackboard for the whole article. I encourage you to look at it, right? What he suggests is this approach, and I've been using this for a while now. It worked great. Everyone knows you can create your own exception, right? We don't have to stick with the standard ones that are given in the framework. You can just inherit from a system exception, and then you can create your own custom exceptions as well. So that's what he suggests, is make an API exception And we're going to design it so it just has an errors collection, an IEnumerable collection of errors that then we can pull the data out of easily once we receive one of these exceptions. Then next is to add a helper method to our project. Right? He actually demonstrates doing this in a console application. I would be tempted in a case like this to, follow through on what I said when we did our last version of this example. Make some sort of a set of helper classes. Right? I'll often make like a utility class where I'll put common utilities I'm going to use throughout the application, things like that. Right? So that might be where I would put my create API exception method. So the idea here is you just pass in the response, and it does all the work of slicing and dicing and pulling all the information it possibly can, figuring out what kind of exception it should create, right? And putting all the data into this simple errors collection in the API exception itself. Then the final thing is in the repository, right? Create and throw this new custom exception. So that approach, we'll look at some code examples of how you actually do it. But again, I really emphasize it's good to read this tutorial. So then in the repository, instead of simply saying like after our asynchronous calls to the web API, we normally in the past just put ensure status code, right? Ensure success status code, I should say. And then that would throw an exception if there wasn't. So instead of that, we'll just do this. We'll check. If it's not success, then, I have a problem. I don't know what, but fortunately I have this nice create API exception utility now, right? So I'll pass it the response, and it can actually generate one of these custom exception objects for me, which I will then throw back, okay, to the calling code. So that's it. It's pretty simple in the, once you create those classes, it's quite simple in your actual repository. All you do is substitute that instead, right? And that's basically it. Then step 3 in your code behind or wherever your code is running, calling the repository to do its work. Okay, you want to catch those exceptions, and our job is to prevent crashes and give feedback, right? So it might look something like this. So if we have one of our custom API exceptions, then we'll wrap a try catch. Remember, we did that already because we want to make sure we catch any exceptions because we've lost connection with the server or the service, right? So one of the catch phrases we might check for is API exception. And this code here, this is right out of his tutorial. I simplified it a little bit, but basically just using a string builder to loop through that errors collection in our custom API exception object and just build up a big long message listing all the problems we see, right? And then I threw my same show message and confirm message that we had in our app object last time. Figured I should put those in my utility toolkit as well, right? So I threw that there, and then we could just say, problem saving the employee, and give them that whole list of errors, right? And away we go. Another example, something like this. This we might have already put in place just to handle those connection errors, okay? So if our general exception, if it wasn't an API exception, if we just have a general exception because we say it couldn't connect, then we can check if the exception message contains some keywords that lets us know it was one of the issues with possibly finding a connection to the server and so on. There you go. So that's it. That's the end of my story for today. Thank you for coming to story time. Trap those errors. Trap those errors. Yeah.